In this version, we have properties of Exponents 3. We're going to use all the properties that we did in the first two worksheets, property of Exponents 1, properties of Exponents 2. We're going to use all those properties, but this time I'm going to really emphasize what's happening with this in the sense that they want us to write with positive exponents, meaning we want positive powers here. So this is all based on your lecture, and you notice here we have a negative power. We're going to use, again, just so you guys recall, x to the n raised to the m. We have an exponential raised to a power. We keep the base, and we multiply our powers. And we're going to use the fact that if I have a negative power, I write this as 1 over the positive power. Division. Again, we keep the base, we subtract the power. Any base to the 0 power is 1. Essentially, this is what we're using. Oh yeah, if we're going to add, or let's go back, if we multiply exponentials, right, we add our powers. So this is kind of a summary of everything that we did, and then we had the distributive property version here, just so you guys remember, x to the n, y to the m, both to the p. So x to the n p, let's write it down here. It's a quick summary of what we're doing. X to the n, y to the m, both to the p power, x to the n p, y to the m p. Okay, so this is a summary of what we're going to be doing in this worksheet. We're going to use all these properties, and we're going to write our final answer with positive exponents. And that'll complete this worksheet, or this idea of properties. So go back, and we have x to the second power, okay, raised to the negative 2 power is x to the 2 times negative 2. X to the negative 4 power. Okay? Again, we're going to use the property where you have to write this exponential with a positive power. And that's going to be 1 over x to the 4th power. And this is what they want us to do for every one of these problems. So let's work on some more. Number 3, x to the negative 3 power raised to the 2 power, or the second power here. We are going to, again, multiply negative 3 with 2. We get x to the negative 6. It's a negative power. 1 over x to the positive 6. And we're done. Let's actually circle our answers. I know that's weird, but doesn't matter. Number 5, x to the negative 4th power to the negative 3 power. Well, we multiply the powers. X to the positive 12th power, because negative 4 times negative 3 is positive 12. And we're done. Number 7, xy squared, both to the negative 3 power. Don't forget, for the x, if there's no power, it's going to be a 1. So again, by using properties, 1 times negative 3 for the x base, 2 times negative 3 for the y base. X to the negative 3 power times y to the negative 6 power. Both of these need to be written with positive powers, positive exponents. Don't forget, we're multiplying these two. You see multiplication here, here. It's really here. They didn't put it there. If it's blank, again, remember, you always know that to be multiplication. And when you multiply two fractions, we multiply horizontally across. So this becomes 1 times 1, over x cubed times y to the 6, or 1 over x cubed y to the 6. And you're done. Number 9, xy to the negative 3 power raised to the 2 power. For the x again, we have power 1. So when we multiply, we get x to the 1 times 2, y to the negative 3 times 2. We distribute that power. 1 times 2 is 2, and negative 3 times 2 is negative 6. So I get y to the negative 6 power, which gives me 1 over y to the 6 power. X squared times 1 over y to the 6. Remember, you're multiplying here two fractions again. Get x to the 6, y to the 6, and you're done. Number 11, x squared y to the negative 5th power raised to the 2nd power. Again, it's the same idea. Remember, we're multiplying here. So I'm going to multiply my powers. X squared times 2 times y to the negative 5 power times 2. Just do your arithmetic. 2 times 2 is 4. Negative 5 times 2 is negative 10. Again, this has to be written as 1 over y to the 10th power. And again, I have x to the 4th times 1 over y to the 10th power. Again, think of this as a whole number and divide by 1. And you multiply horizontally across, because this is how you multiply fractions. We end up with x to the 4th over y to the 10th. And you're done. Number 13, x squared, y to the minus 3rd, both to the negative 4 power. Keep your base, multiply the powers. So 2 times negative 4 is negative 8. Negative 3 times negative 4 is positive 12. Again, we write this base to a negative power as 1 over x to the positive 8th power. So you get 1 over x to the positive 8th times y to the positive 12th. Multiply across y to the 12th over x to the 8th power. And you're done. Number 15, x to the minus 1st power, y to the 5th power, both to the 2nd power. Keep your bases, multiply your powers. One over x squared. 1 over x squared times y to the 10th gives you y to the 10th over x squared. This is number 15. (17) 2 x to the minus 2 power y cubed, both are squared. The base 2 has a power 1. So when I distribute the power here again, notice that 2 is going to get multiplied to all these other powers. The 1, the negative 2, the positive 3. So we're going to get 2 to the 1 times 2, x to the negative 2 times 2, y to the 3 times 2. 2 squared, x to the negative 4th power, y to the 6. Notice a few things. 1 over x to the 4th, and then this 2 squared is really 2 times 2. We know that is 4. So your final answer is going to look like this. 4 times 1 over x to the 4th power times y to the 6 becomes 4y to the 6 over x to the 4th power. And we're done, and that's number 17. Number 19, 3x to the minus 3 power, y to the minus 2 power, raised to the 3rd power. Again, the base 3 has a power 1, so this becomes 3 to the 1 times 3, x to the negative 3 times 3, y to the negative 2 times 3, 3 to the 3rd, x to the negative 9th, y to the negative 6, and again, these three terms have to be simplified. 1 over x to the 9th, 1 over y to the 6, and then 3 cubed, remember, is 27. Putting this all together, we're multiplying here. You multiply again horizontally across. So 27 times 1 times 1 is 27 times x to the 9th, y to the 6th power. And that's number 19. xy to the minus 5th power to the minus 1st power. Don't forget there's a 1 here. So this becomes x to the 1 times negative 1, y to the negative 5 times negative 1, x to the negative 1, and this is times y to the positive 5. One over x. So you have 1 over x times y to the 5th power is y to the 5th power over x. And you're done. X to the negative 3 power, y to the negative 2 power for number 23, and that's raised to the negative 2 power. Multiply your powers. Okay, that negative 2 gets multiplied to negative 3 and negative 2 here. So notice again, negative 2 and negative 2 did in fact get multiplied to negative 3 and negative 2. And yes, multiplication, multiplication. Negative 3 times negative 2 is positive 6. Negative 2 times negative 2 is positive 4. (25) 3x to the minus 3 power, y to the 2nd power, raised to the negative 2 power. Okay. Again, you have a power 1. This gives you 3 to the 1 times negative 2, x to the negative 3 times negative 2, y to the 2 times negative 2. 3 to the negative 2, x to the 6, y to the negative 4. One over 3 squared, 1 over y to the 4th. This gives us 1/9 times x to the 6 times 1 over y to the 4th power. Multiply again across x to the 6 over 9y to the 4th. And you're done. This is number 25. x squared y to the minus 1st over z to the minus 3 power, both raised to the negative 1. Now we're going to use properties of exponents, and let's emphasize what's happening here. This negative 1 power gets multiplied to every power you see here. 2, negative 1, negative 3. Again, the reason being is you have multiplication here. So we can distribute the power. Just multiply that negative 1 with all the other powers. Keep your base. So you should see 2 times negative 1, negative 1 times negative 1, negative 3 times negative 1. Every one of those powers that your bases had is here, and you distributed, meaning you multiplied this negative 1 power on the outside here to every power. And that's what it's going to look like. So your final answer is going to be x to the negative 2, y to the positive 1, z to the positive 3. Now, like we discussed in class here, this x to the negative 2 power, this exponential with a negative power, negative exponent, is in the numerator position. Now, when I replace this with 1 over x squared, we've seen in class that all this did for us was put the x squared on the bottom. In other words, it's in the denominator. So I have finally here y over the x squared is now on the bottom, and my z to the third power, it already had a positive exponent. I'm done. So, refer to your notes about how that worked. We went through this in a lot of detail, this effect. And this is kind of where some people make mistakes. If you have a base with a negative power in a numerator, put it in the denominator with a positive power. I'm going to emphasize it by pointing this out to you. So it was up here in the numerator position with a negative power. It's now in the bottom here with a positive power. Okay. Oops. Lost the answer. There you go. $29. X squared y to the cube power over z to the negative 2 power. Both raised to this is 29, both raised to the negative 2 power. Notice again, I'm going to emphasize something here, that the operation there is blank. By default, that's multiplication. So I'm going to take this negative 2 power on the outside, and we're going to multiply it with every power you see here. This is what it looks like. 2 times negative 2, 3 times negative 2, negative 2 times negative 2. Double check. Every power is here still with your bases, and we did in fact multiply each power by that negative 2. Here's what we get. Negative 4, negative 6, positive 4. Now I'm going to point something out here again and say you have a base with a negative power and a base with a negative power again. In the denominator, we already had a z to the 4th power. It's still there. And remember, you're going to have to write each one of these with a positive power. Since they're in the numerator position, they're now going to be in the denominator. I'm going to put them down here. I guess this is pink. Never tried pink before. Okay. As you guys know, notice they're now in the denominator with a positive power. you are done. This is number 29. X to the negative 2 power, y to the second power, over z to the negative 1 power, everything to the third power. Emphasize that there's multiplication here, okay? And that 3 power on the outside is going to get multiplied to every one of these other powers here. The negative 2, positive 2, and a negative 3. This is what it looks like. So double check. Every power is here, and every power was multiplied by that positive 3 that was on the outside. X to the negative 6 power, y to the 6 power, over z to the negative 3 power. Every one of these exponentials with a negative power has to be placed in the opposite positions, meaning this x to the negative 6 is in the numerator position. It's now going to be, let's use pink, in the denominator. The z to the minus 3 is in the denominator. It's now going to be in my numerator. And this is what my final answer will look like. So I want to go back and emphasize that this is now on the bottom, and this is now on the top, and their powers are positive. We went through that detail in class. And so look at your notes, and this is what you should have as your answer for number 31. 33, x to the 4th power, y to the minus 2 power, over z, both to the 3rd power. Don't forget z has a power 1 here. So what we're going to do, again, is take that 3 power that's on the outside, and we're going to multiply it to every power you see here. We get x to the 4th times 3, y to the negative 2 times 3, over z to the 1 times 3. And double check. My 4 is here, my negative 2 is here, and my 1 is here. Every one of them got multiplied by a positive 3 here. So we get x to the 12th times y to the negative 6 over z to the 3rd power. 1 over y to the 6, or think about this one and say, put me on the bottom. X to the 12th over y to the 6th, z to the 3rd. And that's 33. $35, 5x cubed, y to the minus 1st power, everything over z to the minus 2 power for number 35. This is raised to the negative 1 power. Your 5 has a power 1, and we're going to take this negative 1st power here. And we're going to multiply it to the 1st power, 3rd power, negative 1st power, negative 2 power. This is what it looks like. Negative 1, negative 3, positive 1, z squared. These are both in a numerator position. put me on the bottom. Y 5x cubed z squared. And you're done. (37) x squared y to the fourth 2z to the minus 3 power raised to the negative 2 power. Don't forget this 2 has a power of 1, so we're going to take this negative 2 power and we're going to multiply it with, again, 2, 4, 1, and negative 3. This is what it looks like. 2 to the negative 2, 4, negative 2, 1, negative 2, negative 3 times negative 2. Double check. Negative 2 did in fact get multiplied to every power. 2, 4, 1, negative 3. Negative 4, negative 8, negative 2, positive 6. So notice again here. We're going to move these three terms because they have negative powers. The bases with negative powers in the numerator are now going to be in the denominator with positive powers. That 2 to the minus 2 in the denominator is going to be in the numerator with a positive 2 power. So this is what this will look like. And I'll put it down here. X to the fourth, y to the eighth. That z to the sixth already had a positive power. That's not going anywhere. And then this is 2 squared here. So I know 2 squared is it's actually the value 4. So I'm going to have 4 over x to the fourth, y to the eighth, and then a z to the sixth power. And that's going to be my final answer. And every one of these has a positive exponent here. Okay, this was 37. We finally made it to 39. And 39 is 3x to the fifth, y to the minus 3 power, over z, everything to the third power. Power 1. Power 1. Notice this power, this power, this power, and this power are all going to be multiplied with my 3. This is what it looks like. That 3 got multiplied to 1, 5, negative 3, and 1. So we get 3 cubed, x to the 15th power, y to the negative 9th power, over z to the third power. I know what 3 cubed is, right? 3 times 3 times 3 is 27. This is going to be 1 over y to the 9th, or place it on the bottom. This is what your final answer is going to look like. 27, x to the 15th power, y to the 9th, z to the third power. And you're done. Number 39.